Hello, Intro to Stats class. We're going to do pages 159 to 163, and this is the digital format of new edition of the same book. So you may see different page numbers. But I have quoted the exact page number and example number from your book. So we start from page number 159. There we start with, can we generalize our results based on small samples when we do and conduct an experiment. So whenever we conduct an experiment, we try to find out the changes in explanatory in response variables based on changes in explanatory variables. So what happens when there is a change occurring like this? So basically the change happens in some specific setting. The changes, it could be a specific subjects. Your subjects could be specific when you conducted an experiment, or it could be specific environment, or it could be specific experiment. So it's just a unique situation. It's not that every time you conduct the experiment, maybe your subjects are different, environment is different, or maybe the technique the experiment is conducted, that's different. So can we have the generalization of result based on the given subjects, environment, and experiment? So that is something we have to be the statistician. They have to be very sure. They have to be that the outcome should be statistically significant. All right, the outcome should be statistically significant. And what it is, for that you can see they talk about this thing here on next page, that the first step is to be sure that the findings are statistically significant and they're too strong to often occur just by chance. So we can say should be statistically significant and they are too strong to occur just by chance. It's not that they're just occurring by chance. There should be the evidence should be very strong. Every time you conduct it, you are going to get almost the same kind of result. So let's move to our next example 6.12. In your new edition, but in your book it's 3.12. It's about studying frustration, and it is what actually in this example, a psychologist, she wants to find out the effects of failure and frustration on relationship among the members of a work team. So basically the work is to study the effects of failure and frustration on relationship among members of a team. All right, they're just trying to find that if they just check what's the effect of failure and frustration on teamwork. So what in that case, what they have done, they have three settings. First setting that we talked about in our previous one, where we are talking about the subjects, environment, and experiment. We're going to talk about the same thing here, that our subjects are what? In that case, our subjects are the students. All right, and the environment and the environment is what? In that case, the experiment and the environment is the lab, the psychology lab. And the treatment here in that case, they got the treatment was what? The rigged game was the treatment, the game where they were supposed to lose more often, so that was the rigged game. And then the psychologists observed the change in the behavior of the students from a one-way window and recorded. So now the trouble is here, we're trying to find whether it is applicable to the bigger scenario where there is a session of longer time where people work for many months to develop a new product, and and the work procedure, or sometimes the product they're working on, sometimes it never works right away, or they get frustrated, and how it affects on their teamwork. So sometimes they try their best to make it realistic experiment, but it lacks of realism. But the lack of realism limits the usefulness of the experiment in this area. So what we can say that, like in that kind of situation, lack of realisms limits the usefulness of experiment. So it's always not useful. Now the other example is about center brake lights. It's about center brake lights. The purpose of the experiment was to check whether the center brake light at the rear end of the car that stops the rear end collision, so effectiveness of that beside two extra brakes. So they're just trying to check whether the high center brake, in addition to two usual brake lights at the rear of the vehicle, is it really helpful to reduce the rear end collision? And the experiment had showed that they have 50% reduction in the rear end collision. The experiment based on small group, but actually in a long run, when they just talked to insurance company, they figured out it was just 5% reduction. So here we can summarize here that it's center brake light, that high center brake, so brake light, we were just finding out whether it is effective to reduce rear end collision. So what happened that basically experiment showed that it is according to experiment it was 50% reduced, but when they talked about insurance company, that says it is not 50%, it is just 5% reduction. So why is it so? The reason they talked about here, that when they conducted the experiment that time, they don't used to have that third extra light in the back, so it was kind of very unique. So drivers, they paid attention to the following car, the car in the front, the light, so they were more cautious. But after the experiment was done, so mostly everyone used to have that kind of light, so it was very normal for the whole uh, group of drivers, so they never paid attention to that. So the reduction was not that much bigger in a long run, for 5%, as compared to when the experiment was conducted, and it showed it can reduce it by half. So let's move to example 3.14. That's about our subjects treated too well. Our subjects treated too well. So in this example, we're trying to discuss about when we conduct an experiment, so clinical trials especially, we treat the patients too well so that the success rate is higher. So in that case, let's talk about here. Yeah, so here we're talking about, we're talking about in clinical trial, especially in clinical trials, what happened, the treatment is really ideal for the treatment ideal setting. The setting is ideal means they're getting the best care. The patients and the doctors, they're trying their best, and the whole team, the environment, everything is on the top. So your success rate is comparatively higher. Success rate is higher. But when the clinical trials are done, so in a normal setting, when it comes to the market, then it doesn't show sometime same kind of success rate. So sometimes we have a question: are subjects treated too well? They get best treatment when they do a medical experiment. And there is another study where they talk about this. That's a Carolina Abascadarian project, where they're just talking about whether intensive care has a very good intensive care where they have a very high qualified staff, or a lot of parent participation and a lot of activities. If they try to they try to do an experiment, whether at early age, if the kids in their elementary years, if they get a proper care by a very professional and very engaging way, it shows a positive impact in their later life. And but the cost was 11,000 per year per student. And but the question is, will the society will offer this much support to poor families? So that's a question. Is it really going to be that practical in real life? And also, we talked about so many experiments till now. We talked about frustration. We talked about the car's light, the other higher car light, third one. So in experiment, it's not easy to generalize based on a small sample or small group. Sometimes it is about understanding how people function, not based on the data. It's even harder to generalize from rats to lab to people in the real world. Like, you conduct an experiment on animals and then you try to generalize. It's really complicated. You cannot always generalize it in that simple way. So let's talk about experimental design. In real world, when you do the experimental design, there is another definition: completely randomized experiment. Completely randomized experiment. All right, and what happens if you know that you have X number of treatments. Okay, if you know that you have X number of treatments, so it means you have to create X number of groups. And how are you going to make that group? Like, whatever your subject population is, or the sample for the subject, your allocation has to be random. Allocation of subjects to that X number of groups should be of subjects to that X number of groups should be random. All right, so here that is called completely randomize experimental design, where you first decide how many treatments you're going to give. Based on that, you decide your that many number of, if you're thinking about you're going to have 5 treatments, you decide 5 number of groups, and then you, if you have 100 people over there to study, you just randomly assign them to each and every group, so that it's completely randomized experiment. Let's move to the next page. Here they're just going to talk about another example. They're doing an experiment about durable fabric. Durable fabric. In that experiment, the researcher, they try to find out which kind of cloth and which kind of setting it's going to be durable after a certain number of repeated washing. So it was study about the whole is the study about durability of a fabric under repeated washings. All right, so but when we do when we try to check the durability under the repeated washing, there could be 2 cases that it could depend on a lot of things. It could depend on, like, if you have your cloth and you're just washing it, type of cloth, so you choose the water temperature, the detergent, how harsh you want. So that depends on water temperature. And other thing, it depends on water temperature, and other thing is your cleansing agent. So it's the cleansing agent, means you're using which kind of detergent. So 2 things will decide how durable it is. So in that experiment, what they have done, they basically have 3 levels of water temperature. So they have 2. These 2 are what? These 2 are your explanatory variable. Both are, all right. These 2 were explanatory variable, and that's going to decide your durability of cloth or fabric, durability of fabric, and that's going to be your response variable. All right, response variable. So we are checking how that impacts. So they have 3 different levels of water. They had hot, they had warm, they had cold water. Different temperatures, that's variable A. That's your explanatory variable. And the same way, they have another explanatory variable, that's cleansing agent, that's variable B, explanatory variable. And they have regular tide, they have low phosphate tide, they have ivory liquid. All right, and they have what they have done, they tested this with a piece of treatment consisted of washing a piece of fabric, a small unit, and they tried it 50 times in a home automatic washer with a specific setting. They just tried it with a specific setting, and then they recorded the data. So this way, they have how many? 9 possible treatments. They got 9 possible treatments, and each time that treatment that tried for 50 times each treatment. All right, they tried it 50 times. So they checked and they recorded the outcome for the experiment, and then they saw that how not only temperature alone, cleansing agent, the 2 combination, they work in combination together to check the durability. Is not always the same thing, that they think that just if the temperature is good enough, then nothing is going to happen. It can be the interaction between the explanatory variables. So what, for example, what they have checked, what they have seen, the water temperature may have no effect on strength, when they use a regular tide. When they use the regular tide, that it doesn't have any effect, but after 50 washing. But they have checked, if they're not using a regular tide and they're using a low phosphate tide, and what happened, the fabric, it became weaker when cold water is used instead of hot water. And one thing I forgot to tell you, that durability strength, they had a testing machine, fabric testing machine, where that forces a steel ball through the fabric, records the fabric resistance to breaking. So it checks how durable is that. So yes, they use that machine to check with regular tide, low phosphate. In low phosphate, they saw that it works well with hot water instead of cold water. So there are different things, like in background, different combinations affect. So that is called interaction between cleansing agent and water temperature. So we can say here that it could be, when we check the setting, so basically we found out another term that's called interaction. And interaction is what? It's the combination effect by explanatory variable, how they work together. Sometimes what happens, like in clinical trial, if they're trying to test some kind of medication, so maybe a person who is normal, medication may not have any side effect, but maybe a person who is drinking alcohol or some kind of beer, so becomes unconscious, may have a negative impact with the medicine. So it's really hard sometimes to generalize the total outcome or the result of any experimental design. There are so many things working in background. Sometimes the treatment could not be same. Sometimes the experiment may be the subjects of the experiment may be different, the environment may be different, or sometimes it may be in clinical trial they must be getting too much care, all other things, or maybe it's an interaction which is causing different results each time. So it's really hard. So we can only generalize. So crux of this lesson is basically we can only generalize when we see the results are statistically significant. They're not occurring by chance. They have a real result when we apply to the bigger population. So hope you get it. This was all about this chapter. Till then, stay safe. Thank you so much.